Okay, so what we're doing today is we're looking at how to find general solutions to trigonometric equations. So to do this, we need to think about what this actually means. If we had a sine graph, which I'm just going to sketch a rough one here. So that's our basic sine graph up to 2 pi. It could continue in this symmetric fashion. I know mine is not ideally symmetric, but hopefully you get the idea. From negative 2 pi to 2 pi. Now if I was to solve the equation where sine of x is equal to half, that means that I would be wanting to consider where, if this is a value of 1 here, half would be here. We want to find where is sine of x equal to a half. That would give us the point here, and here, and here, and here. We would get 4 possible values within the domain from negative 2 pi to 2 pi. So if I was solving this equation for the domain from negative 2 pi to 2 pi, we know how to do this. This is solving our trig equations that we've done on a few occasions before. However, where the trouble will come is if we are not given a specific domain. If we don't have a domain, that means that there is infinitely many solutions because our sine graph is going to continue to infinity and to negative infinity, which means there's infinitely many solutions. We cannot logically list infinitely many solutions. It's not possible to list infinitely many anything. What we need instead is a formula that will allow us to produce those solutions. And that formula that will allow us to produce solutions is called the general solution to trigonometric equations. And we're going to look at how to form those today. So in general, this is the formula, and I will explain where this comes from. So if we're trying to find where cos of A is equal to A, so let's think for a minute. Here is our unit circle, okay? If we're solving a value here where cos of A is equal to A. Now notice A is defined as being between negative 1 to 1, and that's because we know, of course, that the value of cos is given by the horizontal displacement, and that can't be greater than 1 or less than negative 1. Let me just change colours for a minute. If we assume that A is positive to start with, that's the easiest way to do it, where cos of A is equal to a positive value. Cos of A is equal here. Cos of A is positive in the first and the fourth quadrant. So how do we get our solutions? Well, to get to our first solution, what we need to do is we'll just have, here is 0, so we can have 0 plus our solution there, which we would find where cos inverse of A. That would give me, this is the corresponding cos value, it's our horizontal value, remember? So I would have 0 plus inverse cos, or I could go around again and have 2 pi plus inverse cos. Or we could go around again and have 4 pi, because this is the same as 0, 2 pi, 4 pi, 6 pi, and so on. Also, if we were going in a negative direction, it would also be the same as negative 2 pi, negative 4 pi. So to get this first solution here, the way we do that is by taking 2 pi and multiplying it by an integer, a negative or positive value. So I'm multiplying it by n, an integer. What I do is, that's then going to give me, if I've got 2 pi multiplied by n, this is going to give me the multiples of 2 pi. And once I've got that, I'm going to add on inverse cos of my angle, okay? Now I need to figure out how to get this other solution here. So how do I get this other solution? Well, in this case, I have to go to these values here, to 0 or 2 pi or 4 pi or 6 pi. So once again, I have 2 pi n, 2 pi multiplied by an integer, but this time I've got to subtract inverse cos of A, okay? And that allows me to get my other value. So what we have here, and this is where this formula comes from, to get our values of x, because remember we want a general formula, a formula that will allow us to get all of the infinitely many solutions. X is equal to 2n pi, which is what we had in both cases here and here, plus or minus, because we can either add cosine to get the solution in the first quadrant or subtract cosine to get the solution in the fourth quadrant. And we either add or subtract the inverse cos of the angle, which is giving us the particular distance. Now this formula works where n is an integer, so when we're saying n is an integer, that means it can be a positive or negative whole number or 0, okay? So it could be -2, -5, 1,000, whatever. We know a has to be between -1 and 1 because this is where we know that our values of cosine have to fit within the unit circle. And this last bit here is important as well. Cos inverse of a has a range of 0 to pi. This solution so far has allowed you to figure out, has allowed me to describe to you how we get the positive solutions. We need a way to get the negative solutions, okay? If cos of x was equal to -a instead, if we were considering where cos of x is equal to -a, that means, let me change colours to show the negative. For a negative value, we would be looking for solutions in the third and fourth quadrant, which means that what we would need to do, and generally the way we work this out is saying pi minus this value, but in order to keep using this whole solution, what we do is we say that we're going to go from this value here, from 0 to pi, around here, so we're adding on this value, or we're coming to get to the other one, we're taking this value and subtracting to get there. This is where this range comes into it. If we're wanting to get our positive value, we look in the first quadrant. To get our negative value, we look in the second quadrant here. This will make a little bit more sense once we do an example, so just keep that in mind at the moment, that this is the range. We need to make sure this range is covering a quadrant in which cos will be positive and cos will be negative. First quadrant where cos is positive, second quadrant where cos is negative. And this will hopefully make a bit more sense once we do some examples. Okay, now let's consider tan. Now once again, we're going to need to look at the unit circle. So let me draw another one just here. And sorry, it's not very circular this time, but that doesn't matter. It will still allow you to see what's going on. So we again label our unit circle, and we do the same thing again. Well, if we're wanting to solve tan inverse of A, tan is positive in the first and the third quadrants. Okay? So let's now look at what we're going to do, how we can find those values. So once again, to get to our first solution here, same as what we were doing before, we're measuring from 0, from 2 pi, from 4 pi. So what we're doing to get to this first solution is we're taking 2 pi multiplied by n, any integer. So 0 would work. If I multiplied by 0, I'd get 0 plus inverse tan of A. So that's how I'm going to get to my first solution. To get to my next solution, what we generally do is that we move around to this point here, which is where we're finding things like pi, 3 pi, 5 pi, negative pi, and we're going to add on a value. So we're taking our odd number values, so we're taking an odd value of pi, which we'll talk about how to get in a minute, an odd value of pi, and we're adding on inverse tan of the angle. Now the easiest way to combine these two solutions together is to look at what we're doing. We're taking an odd value of pi and then adding on tan, or we're taking an even value of pi and adding on tan. That means that essentially to get all of our solutions, we're taking any integer of pi, that's why it just has n pi, and we're adding on inverse tan. So to get our two solutions, we take any value, any integer value of pi. Notice that n is again an integer, and we're adding on inverse tan of our angle, of our value, which was a. A can this time be any of the real values, because of course we know that our value of tan, thinking through what it means again, we've got a tangent here. Our value of tan could be anything. It could be something that is much higher than other values, much bigger than 1. And once again, we need to consider tan or inverse of A. Where is it defined? Like I said before, we need to have it defined in a quadrant that's going to have both a positive and negative value. And by definition, okay, this isn't anything, this is just how it is defined. This is something you need to know. We tend to look at these two solutions here. So when I'm trying to figure out the value of inverse tan of A to substitute into this part of the formula, if A is positive, I find the solution in the first quadrant. If A is negative, I find the solution in the fourth quadrant, but I find it by moving in the clockwise direction. Let's have a look at sine now. Okay, so we consider the same thing once again, and I seem to be running out of space for my unit circles, unfortunately. I might draw it over here to give me a bit more room. So here's my unit circle, okay. We want to know where sine is positive. It's in the first, and, oh, sorry, that doesn't look quite symmetrical at all, does it? Let me get rid of that. Okay, it's in the first and second quadrants. Now the first quadrant, we've already had this before. To get to our first quadrant, what we do is we find our even values, 2n pi, and we add inverse sine of the angle. And that's where this first solution comes from. There's no nice way to put our two solutions together. That's why we've actually got two separate general equations to find this solution. Because to get to my second value, I have to come over here to my odd values of pi, like pi or 3 pi, and then subtract. So I need to subtract inverse sine of A from an odd value of pi. The way that we get our odd values of pi, which you can see here, if we want to get an odd number, we take any integer, any whole number value, multiply it by 2, that will make it even. Okay, so this number by definition is going to be even, and then we add on 1. So what I'm having here, what we're saying is that to get our general solution, we take an even value and add inverse sine of A. Sine of A gives our vertical length to get our solutions in the first quadrant. To get our solutions in the second quadrant, we take an odd value. It becomes odd altogether once I've taken an even value and add 1. We take our odd value of pi and we subtract to get our value here. Okay? Slight typo here. A should be defined between -1 and 1. Can you make sure that you change that on your sheet as well, please? Not for R. And n is once again an integer. Our value of sine is defined between -pi on 2 and pi on 2. So if we're wanting to find the positive value, we are looking here in the first quadrant. For the negative value, we're looking in the fourth quadrant by measuring backwards. Now, one last thing to mention before we go on to our examples. Notice that here the range is given with curved brackets, so -pi on 2 and pi on 2 are not included for pi. That's because, of course, if we were to find inverse tan of pi on 2, it's undefined, so it can't be included. Whereas for sine, pi on 2 and -pi on 2 do have defined values. Okay, so let's look at our example. We're wanting to find the general solution to this particular equation. Now, here's the tricky part. if this question is asked in a tech-active situation, you don't even need to worry about all of this. If we're doing this in a tech-active situation, let me get out of this for a second. All we do is that we get our calculator. Let me just move it over here for a minute so I can see this here. Okay, we get our calculator and we type in our equation. So typing in our equation, cos of x equals 1 over root 2 is what we're wanting. So we get 1 over root 2, okay? Then what we do is we highlight our equation, make sure that it's in radian mode, and we say interactive equation solve. Now what this is doing, it doesn't look like it, but it is actually giving us a general solution. What it's saying is that we're doing 2 pi multiplying by a constant, which is our value n we were talking about, minus pi on 4, or 2 pi plus 2 pi multiplied by a constant, again n, plus pi on 4. That is the general solution. If you are doing this in a tech-active situation, just use your calculator, but do not write constant like this. Just call it n or k or some other parameter. So it's quite easy if it's in a tech-active situation. The problem comes, of course, when we're doing this in a tech-free situation. If we're solving this in a tech-free situation, again, just to make your life more difficult, the general solution formulas are not on the formula sheet. So you either have a choice of memorizing the formulas we just saw on the previous page, or of thinking about what they actually mean again. So we're wanting to solve where cos of x is equal to 1 over root 2, okay? So we just think our cos values, how did we get to them? Well, our first cos value is in the first quadrant and our second one is in the fourth quadrant. So what we need to do to get to this one is we're needing to take 2n pi, we take our even values of pi and we add our base angle, the angle we would find in the first quadrant. To get to this solution here, we take our even value of pi and we subtract our value here. So that was the formula that we established before. So using this formula, when we're solving this, we say that x is equal to 2n pi plus or minus inverse cos of our angle, which is 1 over root 2. Now we need to figure out what this actual value is. Inverse cos of 1 over root 2. So solving this, as I said before, inverse cos is defined for the first and second quadrants. It's defined, let me just change colours once again, in these two quadrants here and here, okay? We're wanting to know inverse cos of 1 over root 2. That's a positive value, so we're looking for our value here. We're looking for the size of this cos value here. So the angle, cos of what, gives us 1 on root 2. The answer, hopefully you all remember, is pi over 4. So we're saying cos of what equals 1 over root 2. And the answer is pi over 4. Let me change colours again. So we get plus or minus pi over 4. Now this is not quite the final answer, because if we set up an equation like this, we need to actually define what n is. It's not enough just to have it written here, we need to clearly define the values of n. So we say that n is an element of z, which remember means that n is an integer. Okay, let's go on and have a look at our second example. So we're wanting to find the general solution to this particular equation, and hence. Now hence means you must use what comes before. Okay? So that means that we can't just go and determine all the solutions for this domain like we would do in a normal situation. Because it says hence, we have to use the general solution. We must determine this first, and we must use it to solve the equation. So my equation is here. I start by dividing both sides by 2. Okay, now I'm ready to solve this. Remember, I'm not solving it for this given domain right now, I'm finding the general solutions. When we think about our unit circle, if we remember before, we were defining sine. Now I know that this is negative, but we don't worry about that right now. We just think about how was our general solution for sine defined. And our general solution for sine was defined by looking at where sine is positive, which means we're looking at the first and the third quadrants. To get to our first value, if you remember, we're having to take our even values because this is where pi has an even value of pi. To get our even values of pi, we multiply an even number, 2n, by pi, and then we're going to add on our special angle, our base angle, that we find that makes up this quadrant here. We're going to add on that base angle. To get our second value here, what we need to do is to take our odd values, because this is where our odd values of pi are, and remember, to get our odd values, we get an even number by multiplying an integer by 2, and then we add 1, and we're going to multiply that by pi. So that's going to take us all around to this value here, and then we're going to need to subtract the size of the angle. So we're subtracting inverse sine of A. So this in here has our value of A, that's the size of our angle there. This is A here as well. So these are our solutions. So what we will get when we solve this, we're getting x plus pi over 3, that's still the argument, I haven't taken care of the pi on 3 yet, is equal to, for the solution in the first quadrant, we get 2n pi plus inverse pi of the value that it's equal to, which in this case is -1/2. Or our second solution, because remember we could get multiple solutions in this case. The other solution that we get for sine is that we're going to get 2n plus 1 pi, and we're going to subtract inverse sine of my value there, which is 1/2. Okay, so this is what we've got. This is what we are looking at in this case. What we need to do now is to figure out what this value of inverse sine of 1/2 is actually equal to. Excuse me as I keep changing colours here. So this is what we're trying to find out. We're trying to find out what inverse sine of -1/2 is equal to. We look in our unit circle. Now what we need to remember is that sine was defined with a range from -pi on 2 to pi on 2, okay? So it was defined for these two quadrants here. These ones don't exist for our thinking right now. We're going to positive pi on 2 or to negative pi on 2. We want to know for which of these two quadrants here is sine negative. So we're going to find where sine is -1/2. And we're going to find that value in the fourth quadrant. Okay, so let's think about this now. We want to find it in the fourth quadrant. We want to find it in this part here. Okay, so what we're going to do then is that we are going to have to find this angle here, because it's not the fourth quadrant really, we're moving in the negative direction. So our answer is going to be the negative value of whatever sine inverse of 1/2 is equal to. Sine inverse of 1/2, we should all remember, is equal to pi over 6, so we get a value of -pi over 6. So let's change colour again and substitute this back into our equation. So we're going to get 2n pi plus from here, but it's a negative pi over 6 because that was the value we found here. This is how that negative part comes into play. Or our other solution is 2n plus 1 pi minus our negative pi on 6 value. Now I'm going to simplify this a bit because it's a bit messy for us to deal with right now. And we still have to subtract the pi on 3 from here. We still have to deal with that. This first one here, we can't really simplify that very much, so I'm just going to leave it as 2n pi minus pi over 6. But our second solution, if we expand this bracket, that's the same as 2n pi plus pi over 6. Okay? If I subtract, because remember, this is the same as saying x plus 2 pi over 6 if we're wanting a common denominator. So to find our values of x, I'm now going to subtract pi over 6 from both sides of my equation. Here I've got negative pi over 6 minus 2 pi over 6. That's going to give me negative 3 pi over 6. Here what I will have is 2n pi plus pi over 6. Okay, pi plus pi over 6. So that is 7 pi over 6 minus 2 pi over 6. That's going to give us plus 5 pi over 6. Okay, so this is where we're getting our solutions from. And again, we can simplify this to give us pi over 2 or 2n pi plus 5 pi over 6. So let's stop for a minute and have a look at what this would look like on our calculator. Let's check. So I'm just going to end this slideshow for a minute, but I do want to keep all of my annotations. Okay, so here's our value here. So if we type this in this time, our equation, 2 sine of x plus pi over 3, okay, x plus pi over 3. We want to know where is it equal, where is it equal to negative 1. We highlight interactive equation solve, and we're getting the value here of 2 pi multiplied by n, our constant, 2 pi n, which is what we wanted here, minus pi over 2, yes, that matches, or 2 pi multiplied by a constant, our value of n here, plus 5 pi over 6. So notice that we get the same solutions in either case. Once again, if it's in TechActive, I would just do it on your calculator, but never write constant like this. Always put a value of n or k in there. Let's pop back into this slideshow and finish off the rest of this question. So we do, of course, need to make sure that this is not finally finished. We do need to define n. Let me just change back to blue just so it's all matching in nicely. So these are our general solutions where n is an integer. Okay, we do need to write that. That's the first part. The second part is hence determine all solutions between negative 2 pi and 2 pi. So I'm going to need a little bit more space on my board here, so I'm just going to rub out, maybe I'm not. Oh, I can't rub it out because I've left and came back. Okay, so I'm not going to be able to do that. Let's see if I can squeeze it in up the top here somewhere. Excuse I'm going to start writing all over the place, so please bear with me, everybody. We want to determine our actual solution. So what we do then is we substitute in some specific values. We say, okay, well, if n equals, if n is equal to 0, what solutions would we get? We could get, substituting n equals 0 here, that would be 0 minus pi on 2, so negative pi on 2 is a solution. If I substitute 0 in there, 0 plus 5 pi on 6, so 5 pi over 6 is a solution. Then what about if I try where n is equal to 1? I would get x equals, substituting in 1 here will give me 2 pi minus pi over 2, which is equal to 3 pi over 2. Substituting in n equals 1 here, I would get 2 pi plus 5 pi over 6. But if I'm trying to work that out, 2 pi plus 5 pi over 6, hopefully you can see straight away that's going to be outside of the domain that we were given. So this solution is not valid. Let's try some other values. If I was to try n of 2, that would give me 4 pi minus pi over 2. That's too big. And this one will definitely be too big as well. So let's try some negative values. N equals negative 1. So that would give me, the first option here would be giving me negative 2 pi minus pi over 2. Negative 2 pi minus pi over 2. Even without working this out, we can see this value will be smaller than pi over 2. That's outside of the domain. Our other value here, negative 2 pi plus 5 pi over 6. Well, yes, that one does work out for us. Negative 2 pi is the same as negative 12 pi over 6. So we've got negative 12 plus 5 is equal to negative 7 pi over 6. So therefore, our solutions are going to be that x is equal to, we generally list them from smallest to largest, negative 7 pi over 6, negative pi over 2, 5 pi over 6, and 3 pi over 2. So we have our solutions. Just bear in mind, this most important word here again, hence. Hence means we must use the information that came before. Okay, so that's how we solve solutions and we come up with our general solutions to the equations. Thank you for watching.